Hi everyone, and this is Sandeep, and you are watching Samyan's Academy. And in this session, we are going to discuss about current electricity part 2. Let us start now. Resistance of metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? And also you predict the material of the wire. Okay, by using these values you have to find the value of the resistivity. Rho value you have to find out by taking that rho value. You have to compare the material of the wire. Okay, let us start now. Resistance of the metal wire having the length is how much? 1 meter. So length is given here 1 meter, and the resistor wire is having the resistance value is 26 ohm. Okay, resistance of the metal wire of length 1 meter and which is having the 26 ohm resistance, and the diameter of the wire is given how much here? 0.3 mm. 0.3 mm means millimeter. So 1 millimeter equal to how many meters? 10 power minus 3 meters. So this we can write as 3 into 10 to the power of minus 4 meter. This is the diameter of the resistor wire. Okay, length resistance. Then area, how will you calculate area? We know that the value of the formula of the area of circle is pi r square. Ante the wire which is in the form of circular shape. Okay, so this is a wire. Yeah, this cross section we are measuring, right? So we have to take the cross section area of this wire, means this is in the circular shape. You have to consider your area is pi r square. Okay, then what is the r value? Your radius means diameter by 2, d by 2 whole square. So this we can write as pi into d square by 4. This is a now see here, area equal to pi r square, pi into d by 2 whole square, area equal to pi d square by 4. Now you take the formula. What is the formula for the resistance? R equal to rho into L by A. You consider that formula, R equal to rho into L by A. Take that formula, R equal to rho into L by A. So from this formula, so you have to find out the value of the resistivity. You change this formula into resistivity. So by A you take it here, RA into L. When you take it this side, it will become by L. Okay, rho equal to RA by L. What is the value of R given? That is 26. Sorry, first you convert this formula into convenient form, R into pi d square by 4 into L. Now you substitute the values here. Okay, so R value is how much here? 26, and pi value already know that 3.14, and diameter value is 3 into 10 to the power of minus 4 whole square by 4 into 1. Okay, when you do the calculations, and then you will get the answer here. Just a minute. Okay, now you do the calculation now. Rho equal to 26 into rho equal to 26 into 3.14 into, yes, and here we have the 3 into 10 to the power of minus 4 whole square. So this we can write as 9 into 10 to the power of minus 8 by 4 by 4. Okay, 26 into 3.14 into 9 into 10 to the power of minus 8 by 4. Okay, you use two table, 2 13 times, 2 1.57 times. Okay, 13 into 1.57 into 9 into 10 to the power of minus 8. Okay, 13 into 9 is 117 into 1.57 into 10 to the power of minus 8. Okay, so multiply this 117 into 1.57, around you will get, this is a value around 183.69 into 10 to the power of minus 8. When you do the multiplication, you will get this value 183.69 into 10 power minus 8. So adjust the decimal up to 10 to the power of minus 6. So you take here 1.8369 into 10 to the power of minus 6. This we can write as 1.84 into 10 to the power of minus 6 ohm meter. And this value is matching with the manganese material. Okay, and this value is matching with the manganese material, right? This is the resistivity of the manganese. So resistivity of the manganese is how much? 1.84 into 10 to the power of minus 6 ohm meter. Okay, from this value we came to know that the material of the wire is manganese. Okay, is it clear? Okay, move on to the next question. Here we have a wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and area of cross section 2A? Okay, you are taking the two wires. One wire is having the length L and area of cross section is A. Then the wire is having the resistance is how much here they given? 4 ohm. Okay, you are taking the same material of the wire. So in that wire the length becomes half and area becomes 2 times. Then what would be the resistance of the new wire? Okay, here material of the wire is same. Okay, you are changing the length and area only. Then the value of the resistance of the new wire, how do you calculate? So in this way we can calculate. So the resistance, already we have the formula rho into L by A. Okay, the wire with length L and area A having resistance is how much? 4 ohm. R value is how much? 4 ohm. This is the resistance of that wire. So you are doing some changes. So what are the changes you are doing? So length is half, length becomes half here, length becomes half, and area becomes 2 times of the first one, right? Then the new resistance is how much? Then how do you calculate this new resistance? Take this formula, R dash equal to rho into L dash by A dash. Just you substitute the values here. What is the L dash value here? L dash value is L by 2. L dash value is L by 2, and area becomes how many times? 2 times. 2 into A. So this we can write as rho into L by 4 into A. By 2 when you take it here, it will become 4. Rho into L by 4A. So this we can write as 1 by 4 into rho into L by A. What is the rho into L by A from equation 1? What is the rho into L by A? Rho into L by A indicates the resistance. Okay, so 1 by 4 into from this we can calculate the resistance of the other wire. R dash equal to 1 by 4 times of R. What is the R value given? 4 ohm, right? So just you substitute the 4 by 4 is how much? So when you calculate this, you will get 1 ohm. 4 get cancelled. Answer is 1 ohm. Okay, now what is the resistance of the another wire we got here? 1 ohm. So in this way we can calculate the resistance. It is very important one. Okay, right, is it clear everyone? So you are giving material of the wire some length L and area A, and having some resistance values also they will give. Okay, so in this case you are taking the another wire having the same material of same wire, but length becomes L by 2, area becomes 2 times of the A. Already you know that resistance is directly proportional to length and inversely proportional to area. Here length reduces to half, area increases to 2 times, means resistance of the wire decreases to 4 times. Okay, so the new resistance of the wire is having how much resistance? 1 ohm. Okay, in this from this formula we easily know that if resistance length is half and area becomes more, then that means the resistance reduces to somewhat. That is how much it is reducing here? 1 by 4 times it is reducing. Is it clear everyone? Okay, move on to the next one. Yeah, here we have some questions, in text questions. On what factors does the resistance of a conductor depends? Okay, resistance of a conductor a factor paina depend avutundi. Already you know that, already we discussed resistance, the factors affecting the resistance is length, area of cross section, and nature of its material. Okay, and move on to the next question. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? సో ఇక్కడ ఏమడిగారంటే విల్ కరెంట్ ఫ్లో మోర్ ఈజీలీ త్రూ ఏ థిక్ వైర్ ఆర్ థిన్ వైర్, అంటే కరెంట్ అనేది థిక్ వైర్లో ఈజీగా వెళ్తుందా థిన్ వైర్లో ఈజీగా వెళ్తుందా? ఆల్రెడీ నో దట్ థిక్ వైర్లో ఈజీగా వెళ్తుంది. ఎలా అంటే ఏరియా ఎక్కువ అయితే రెసిస్టెన్స్ తగ్గి ఫ్లో ఆఫ్ చార్జెస్ చాలా స్పీడ్గా మూవ్ అవుతాయి, సో కరెంట్ కూడా ఎక్కువగా ఉంటుంది. ఓకే, థిన్ వైర్ అంటే నారో రోడ్ లాగా ఊహించుకోమని చెప్పాను కదా లాస్ట్ వీడియోలో. సో నారో రోడ్ లాగా ఊహించుకుంటే నారో రోడ్లో చాలా అంటే ఆ రోడ్ కండిషన్ కూడా బాగాలేదనుకుంటే వెహికల్స్ అన్నీ చాలా స్లోగా మూవ్ అవుతాయి. అంటే నారో రోడ్లో వెహికల్స్ స్లోగా మూవ్ అవుతున్నాయి అంటే హై రెసిస్ట్ చేయబడుతున్నాయి. ఓకే, ఇఫ్ ఏరియా ఈస్ లెస్ రెసిస్టెన్స్ ఈస్ మోర్, ఇఫ్ ఏరియా ఈస్ మోర్ resistance is less. Okay, so from so we can say this answer, the current will flow more easily through a thick wire నుంచి కరెంట్ ఈజీగా మూవ్ అవుతుంది. దేనికంటే కూడా థిన్ వైర్ కంటే కూడా, థిన్ వైర్ ఆఫ్ సేమ్ మెటీరియల్ కంటే కూడా. దెన్ లార్జర్ ద ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఆఫ్ ఏ కండక్టర్, మోర్ ఈజ్ ద ఈజ్ విత్ విచ్ ద ఎలక్ట్రాన్స్ కెన్ మూవ్ త్రూ ద కండక్టర్, దేర్ ఫోర్ స్మాలర్ ఈజ్ ద రెసిస్టెన్స్ ఆఫ్ ద కండక్టర్. అర్థమవుతుందా? థిక్ వైర్లో ఏమవుతుంది, కరెంట్ అనేది ఈజీగా ఫ్లో అవుతుంది థిన్ వైర్ కంటే కూడా సేమ్ మెటీరియల్ తీసుకున్నప్పుడు. లార్జర్ ద ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఆఫ్ ఎ కండక్టర్, అంటే ఏరియా ఆఫ్ ద కండక్టర్ చాలా ఎక్కువగా ఉన్నప్పుడు అప్పుడు ఎలక్ట్రాన్స్ ఈజీగా మూవ్ అవుతాయి. మోర్ ఈజ్ విత్ విచ్ ద ఎలక్ట్రాన్స్ కెన్ మూవ్ త్రూ ద కండక్టర్. ఓకే, దేర్ ఫోర్ స్మాలర్ ఈజ్ ద రెసిస్టెన్స్ ఆఫ్ ద కండక్టర్, అంటే చార్జ్ ఈజీగా మూవ్ అవుతుందంటే రెసిస్టెన్స్ ఎలా ఉంటుంది, చాలా తక్కువగా ఉంటుంది. ఓకే, now move on to the next slide. Here we have some more questions. Let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? Okay, here the given in the question they given, let the resistance of an electrical component remains constant, అంటే R value constant గా ఉంది, right? While the potential difference across the two ends of the component decreases to half, అంటే V value V by 2 అయితే decreases to half its former value, then what change will occur in the current through it? అంటే కరెంట్ ఏమవుతుంది మీకు ఆల్రెడీ అకార్డింగ్ టు ఓమ్స్ లా, సో V is proportional to I when R is constant. ఆర్ వాల్యూ కాన్స్టెంట్గా పెట్టినప్పుడు వీకి అండ్ ఐకి మధ్యలో, ఆర్ వాల్యూ కాన్స్టెంట్గా పెట్టి వీకి ఐకి మధ్యలో అంటే వోల్టేజ్ని పెంచడం అప్పుడు కరెంట్ వాల్యూ కూడా పెరుగుతుంది. వోల్టేజ్ని మీరు హాఫ్ ఆఫ్ ద టైం అంటే వీని V by 2 చేశారు అంటే ఆఫ్ చేస్తారు. వోల్టేజ్ ఆఫ్ అయితే కరెంట్ వాల్యూ కూడా ఆఫ్ అవుతుంది. ఓకే, సో ద ఆన్సర్ ఈస్ వెన్ పొటెన్షియల్ డిఫరెన్స్ ఈజ్ ఆఫ్, ద కరెంట్ త్రూ ద కాంపోనెంట్ ఆల్సో డిక్రీజెస్ టు ఆఫ్. ఓకే, of its initial value. This is according to Ohm's law, V proportional to I. What is the formula of Ohm's law? V proportional to I. అంటే వోల్టేజ్ ఆఫ్కి తగ్గితే కరెంట్ వాల్యూ కూడా ఆఫ్కి తగ్గుతుంది. Is it clear everyone? Okay, move on to the next slide. Now here one more question we have here. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? ఓకే, అంటే ఎలక్ట్రిక్ టోస్టర్స్లో ఎలక్ట్రిక్ ఐరన్లో వాడే మెటీరియల్ నార్మల్ మెటల్స్ తీసుకోకుండా అల్లాయ్స్నే ఎందుకు తీసుకుంటున్నాము? ఆల్రెడీ యు నో దట్ అల్లాయ్స్ ఆర్ హ్యావింగ్ ద హై రెసిస్టివిటీ వాల్యూస్, రైట్? బికాస్ ఆఫ్ హై రెసిస్టివిటీ వాల్యూస్ దే ప్రొడ్యూస్ ద మోర్ హీట్. Okay, so because of this reason we are using as a heating element, and also they do not get oxidized. Alloy do not get oxidized means they do not burn. So because of this reason we are using as a heating element. Okay, the coils of electric toasters, electric irons and other heating devices are made of an alloy rather than a pure metal because the resistivity of an alloy is much higher than that of pure metal. ఓకే, అంటే ఇక్కడ ఏం చెప్తున్నారంటే రెసిస్టివిటీ పెరుగుతుంది ఎప్పుడు రెండు లేదా అంతకంటే ఎక్కువ మెటల్స్ కలిసి ఒక అల్లాయ్గా చేసినప్పుడు అవి ఇండివిజువల్ మెటల్స్ ఏ మెటల్స్ తోటైతే తయారు చేయబడ్డావో ఆ మెటల్స్ వాల్యూ కంటే, ఆ మెటల్స్ యొక్క రెసిస్టివిటీ వాల్యూ కంటే కూడా చాలా చాలా ఎక్కువగా ఉంటుంది రెసిస్టివిటీ. దేనికి? అల్లాయ్స్కి. అల్లాయ్ యొక్క రెసిస్టివిటీ వాల్యూ చాలా ఎక్కువగా ఉంటుంది ఇండివిజువల్ మెటల్స్ కంటే కూడా. Okay, and alloy does not undergo oxidation or burn. Oxidation means you have to assume as your burn. అంటే you have to understand your oxidation means in presence of oxygen ఏదైనా బర్న్ అవుతుంది కదా, అందుకే ఆక్సిడేషన్ ఆర్ బర్న్ అన్నాం. సో an alloy does not undergo oxidation or burn easily even at high temperature when it is at red hot. చాలా ఎక్కువ టెంపరేచర్ ఉన్నా సరే అలాయ్స్ అనేవి బర్న్ అవ్వకుండా ఉంటాయి. కాబట్టి ఈ రెండు రీజన్స్ వల్ల మనం ఈ ఎలక్ట్రిక్ టోస్టర్స్ అండ్ ఎలక్ట్రిక్ ఐరన్స్లో అల్లాయ్నే యూజ్ చేస్తున్నాం. రైట్, మూవ్ ఆన్ టు ద నెక్స్ట్ క్వశ్చన్. యూజ్ ద డేటా in table 12.2 to answer the following. So which among the iron and mercury is a better conductor? Which material is the best conductor? Okay, so here we have to compare the two metals. Here iron is there and one more metal is mercury. Mercury is a liquid metal. Then what is the resistivity of the iron is here? By using the table, 10 into 10 to the power of minus 8 ohm meter, right? And resistivity of mercury is how much here? 94 into 10 to the power of minus 8 ohm meter. Both are having 10 power minus 8, 10 power minus 8, no problem. You see this value 10 and 94. Which one is having more value here? Which one is having more value? Mercury is having the more value, means the resistivity of the mercury is more. And which one is having the low resistivity value? Iron is a low resistivity value. So now you tell which one is a good conductor here. Nice, good. Which one is good conductor here? Iron is a good conductor because it is having the low resistivity value compared to the mercury. Thus iron is a better conductor because it has a low resistivity than mercury. Because in the next question they have asked for, in the given table which material is the best conductor. So among that given value, the silver is having the low resistivity value compared to all other given materials. That means here silver is the best conductor. I will show you the table now. You see the table is here. Now you see what is the value of silver here? 1.6 into 10 to the power of minus 8 ohm meter. Okay, so by using this table we can know that easily the silver is having the low resistivity value, means it is a good conductor, right? Here they have asked for the iron and what is that another one? Iron and mercury. Yes, iron and mercury. Iron is 10 into 10 power minus 8 and mercury is having 94 into 10 to the power of minus 8 ohm meter. So which one is the best conductor here in between iron and mercury? Iron is the best conductor. Then move on to the our present slide. It is this one. No, other one. So now it is because silver has a lower resistivity. What is the value of the lower resistivity value here? Silver is having 1.6 into 10 to the power of minus 8 ohm meter. Therefore silver is the best conductor. Is it clear everyone? Okay, move on to the next slide. Resistors in series. So now our topic is resistors in series. Before that we have some two activities. In that activities they have given the three resistors which we are connected in end to end like this, okay? And also these three resistors connected to a battery of the source, right? This is the voltage V. Okay, in this activity, so first what we are doing here, so when you switch on this battery, the current is flowing through these resistors. Okay, when you connect the resistors like this, this is said to be series combination. One end of the resistor is connected to other end of the another resistor. Like this you are connected to other resistor also. The three resistors are connecting in the series pattern. Okay, now these resistors are in series combination. Okay, so after connecting like this, so first you have to check the current, how much current is flowing in this circuit. Then how do you check the current value? Yes, how do you know that the value of current? Okay, yes, that is ammeter. By using the ammeter we can calculate the current in the circuit. Then how do you connect the ammeter? Yes, very good. So ammeter we can connect in series. Okay, let us say this is the ammeter. I am connecting here the ammeter, so having the plus and minus between these two resistors I am connecting. Check the value of the ammeter now. Okay, you note down the reading 1 between the R1, let us say this is R1 and R2 and this is R3. Okay, between R1 and R2 you measure the current value. You note down here the current value, you note down here. Okay, let us say that is I1. Similarly, here we have the another you change the position of the ammeter. Now you take it here, plus and minus. Now you check the value of this current in between R2 and R3. Again you note down the value here, R2 and R3, the current value is I2. Similarly, you check anywhere in the circuit. Again you check anywhere in the circuit. Let us say that is that is, yeah, let us say that is E. So you connect like this, plus to minus. Okay, now you check the current here. Let us say that is I3. Anywhere in the circuit I am connecting. So after taking reading this, our observation is the current value is same in all cases. Means thus in the series the current value is always same. Anywhere you can take in the circuit between R1 R2 or between R2 R3, or anywhere in the circuit you can take, the current value is always remains same. Okay, then how do you are calculating, how do you are checking this? By using the ammeter. Then ammeter, what purpose we are using? To measure the current value. How you are connecting this ammeter? In the series, right? Now another activity is there. In this activity, so what we are doing here, we are asked to find out the volt between the R1 and voltage resistor R1 and resistor R2, and voltage drop here. They are asked to voltage drop. You check the voltage drop here, how much it is. Here it is how much, here it is how much. అన్ని వోల్టేజ్లు సేమ్ వస్తున్నాయా, డిఫరెంట్గా వస్తున్నాయా, చెక్ చేయండి. ఓకే, then how do you connect this voltmeter? Yes, voltmeter, remember voltmeter you have to connect always in parallel, right? Voltmeter always we have to connect in parallel. Okay, this is the 3 resistors we connected to the battery like this. Okay, now we want to measure the voltage. This is the battery is having some voltage V, right? So what I am doing here, let us say this is R1 and R2 and R3. Okay, to calculate the voltage across the R1 resistor, R2 resistor and R3 resistor, then how do you connect the voltmeter? Okay, in the electric circuit, how do you connect? Yes, that is in parallel. Very nice, that is in parallel. Means you have to connect like this. This is V1. Okay, check the voltage now, how much it is. You note down the V1 value. Okay, here you note down. Similarly, you check the voltage value here also by taking this voltmeter here. Again you connect in the parallel. You check the voltage drop here, how much it is. Now you just note down the reading, that is V2. Okay, next time, yeah, now this voltmeter you connect across the resistor 3 and check the V3 value. Okay, check the V3 value now. Again, yeah, after taking all these readings, we can conclude that this combination of all these values gives the voltage of the battery value, the total source value it is giving. For example, let us say the source value is 6 volt. Anukundam, let us say the source value is 6 volt. The battery is giving this much volt, right? Let us assume the V1 is 1. Okay, V1 is the V1 value is 1 volt. Let us say this is having 2 volt. Now the another one is 3 volts. Okay, when you combine all these volts, V1 plus V2 plus V3, okay, 1 plus 2 plus 3, this is equal to 6 volt. This is the battery voltage, right? It is equal to capital V, right? So in the so from this observation or from this activity, we observe that, okay, combination of V1 V2 V3 gives the voltage of source, and voltage of source value means source is having this much voltage, and a combination of all individual voltage values is equal to total battery voltage. That is, అంటే సర్క్యూట్లో బ్యాటరీ ఇచ్చే వోల్టేజ్ అనేది డ్రాప్ అయిపోతుంది. రెసిస్టర్ 1 దగ్గర కొంచెం డ్రాప్ అవుతుంది, రెసిస్టర్ 2 దగ్గర కొంచెం డ్రాప్ అవుతుంది, రెసిస్టర్ 3 దగ్గర కొంచెం డ్రాప్ అవుతుంది. వీటన్నింటినీ కంబైన్ చేస్తే వచ్చిన వాల్యూ టోటల్ బ్యాటరీ యొక్క వోల్టేజ్ వాల్యూకి ఈక్వల్ అవుతుంది. Is it clear? And from these two activities, we confirm that in series combination the current value is same. Anywhere you can check the current value between the R1 R2 and R2 R3 or R3 or anywhere in the circuit also, it is giving the same value. Okay, ammeter is showing the same value, means the current value is same, right? In the similarly, so now when you connect the voltmeter parallel to the each resistor, we observe that the voltage values are different. Okay, and also we observe that when you combine all these values, we get the voltage of the battery, total source battery ante దీనికి ఎంత voltage ఉందో ఆ వాల్యూ వస్తుంది. అంటే ఇస్ V1 plus V2 plus V3 equal to క్యాపిటల్ V. అంటే ఇక్కడ వోల్టేజ్ అనేది ఏమవుతుంది, డ్రాప్ అవుతుంది. ఆ డ్రాప్ అయిన వోల్టేజ్ అన్నిటిని యాడ్ చేస్తే బ్యాటరీ ఇచ్చిన వోల్టేజ్కి ఈక్వల్ అవుతుంది. ఈజ్ ఇట్ క్లియర్? ఫ్రమ్ దిస్ ఎక్స్పెరిమెంట్ we conclude that in the series combination the current value is same, the voltage value is different, right? Then how do you check this? By using the ammeter and the voltmeter. The total voltage equal to sum of the voltage drops. Are you able to see this? Right. So this is the way you have to derive the resistors in the series. So again I will show you here itself. Okay, now you see I'm removing this, right? One more time I'm plotting this. Now you see here we have the three resistors having the value R1, and one more is having the value R2, and one more is having the value R3. Okay, which we are connected in the series with having battery of like this is the battery. It is a combination of two or more cells. Okay, now yeah, already you know that in the in the circuit the current value is same. Anywhere you can check the current value is same, but the voltage value is different. Okay, let us assume the voltage drop across R1 resistor is V1, the voltage drop across R2 resistor is V2, the voltage drop across R3 resistor is V3. Okay, now I am going to derive the equivalent resistance or total resistance in the circuit. Okay, I am going to derive the formula for the total resistance in the series circuit, series combination. Now already you know that in the series which one is same, the current value is same. Okay, from voltage will become, the voltage is the sum of the individual voltages and voltage drops, that is V1 plus V2 plus V3 according to Ohm's law. Already you know that. So according to Ohm's law, what is relation between VIR? Okay, V equal to IR. Okay, so V equal to IR, then V1 equal to, yeah, V1 is the voltage across the R1 resistor, and how much current is flowing through this R1 resistor? I current is flowing, means here I is same, but resistor value is how much here? R1. Then V2 equal to, similarly IR2, V3 we can write as IR3. Okay, so in all these values or all these formulas, you just substitute here in the given equation. So V equal to V1 plus V2 plus V3. So when you substitute here, what will you get here? V equal to V1 plus V2 plus V3. What is the V value we have here? I into R. I into R. So I into R1. V1 value is I into R1. V2 value is I into R2. V3 value is I into R3. I you take common here. So R1 plus R2 plus R3. So I into R. Both sides I get cancelled. Then the total resistance value is equal to sum of all individual resistance. Okay, in the series combination, the resistance value is increases when compared to the other individual resistance values. Okay, this is about the resistance value in the series combination. Is it clear everyone? Right, now you see in this way, so you have to derive what is series combination. When two or more resistors are connected end to end, the arrangement is called as series combination. Is equal to sum of the voltage drops. We can write like this: V equal to V1 plus V2 plus V3. Voltage across the each resistor we are checking like V equal to IR, V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So all these values you substitute in this equation, then you will get this: R equal to R1 plus R2 plus R3. When several resistors are joined in the series, the resistance of the combination Rs equal to sum of their individual resistance R1, R2, R3 and is thus greater than any individual resistance. అంటే దాని అర్థం ఏంటి, టోటల్ రెసిస్టెన్స్ వాల్యూ అనేది సమ్ ఆఫ్ ఇండివిజువల్ రెసిస్టెన్స్కి ఈక్వల్ అవుతుంది. సో వచ్చిన వాల్యూ అనేది ఏ ఒక్క ఇండివిజువల్ రెసిస్టెన్స్ వాల్యూని చూసుకున్నా కానీ దానికంటే ఎక్కువగా ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ఇక్కడ R1 వాల్యూ 1, R2 వాల్యూ 2, R3 వాల్యూ 3 అనుకుందాం. ఇది 1 ఓమ్ అనుకుందాము, ఇది 1 ఓమ్ అనుకుందాము, ఇది 2 ఓమ్ అనుకుందాము, ఇది 3 ఓమ్ అనుకుందాం. ఈ మొత్తాన్ని యాడ్ చేయండి, టోటల్ రెసిస్టెన్స్ ఏమొస్తుంది, Rs ఈక్వల్ టు 1 + 2 + 3 విచ్ ఈజ్ ఈక్వల్ టు 6 ఓమ్. ఓకే, 6 ఓమ్. అంటే దాని అర్థం ఏంటి, దాని అర్థం ఏంటి, ఈ టోటల్ రెసిస్టెన్స్ వాల్యూ అనేది 6 ఓమ్ అనేది R1 వాల్యూతో కంపేర్ చేసిన తక్కువగానే ఉంది, R2 వాల్యూతో కంపేర్ చేసిన తక్కువగానే ఉంది, R3 వాల్యూతో కంపేర్ చేసినప్పుడు కూడా తక్కువగానే ఉంది. అంటే దిస్ టోటల్ రెసిస్టెన్స్ వాల్యూ ఈజ్ వెన్ యూ కంపేర్ విత్ ద R1 it is showing the lesser value only. What is the total resistance value? 6 ohm. When you compare with the R1 and it is having the less value, and with compare with the R2 also, and this total resistance value is more but R2 value is less. And when you compare with this Rs value with R3, which one is more here, Rs value is more, R3 is less. అంటే ఏ ఇండివిజువల్ రెసిస్టెన్స్తో కంపేర్ చేసినా కానీ టోటల్ రెసిస్టెన్స్ వాల్యూ అనేది ఎక్కువగా ఉంటుంది. ఓకే, దిస్ ఈజ్ అబౌట్ సిరీస్ కాంబినేషన్. And move on to the next slide. And based on this series combination, so now we have some problems here. Now let us see these problems. Here we have an electric lamp whose resistance is 20 ohm. Okay, are you able to see this figure? Yes. Now you see, I will draw one more time here. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 volt battery. Calculate the total resistance of the circuit, the current through the circuit and the potential difference across the electric lamp and conductor. Now you see, so what you have to find out here, ఇక్కడ మనకి ఏమి ఇచ్చారు, ఒక ఎలక్ట్రిక్ ల్యాంప్ ఉంది. Let us say I am drawing one more time here. So all of you please observe this. This is the one resistor is there. So to this in series we connected one lamp here. This is one lamp symbol, this is the symbol of the lamp, and we connected to this source battery. This is battery, combination of cells we called as battery. And here we have a meter, right? A meter, it is connected to the negative terminal, means this side is negative. And here we have switch key and other side is positive. So key we represented with the letter K, and this is the bulb and this is the resistor, right? Now what is the value of the resistor given here in the question? This is 4 ohm. Okay, 4 ohm. What is the resistance of the electric lamp? Electric lamp resistance is 20 ohm. How much it is? 20 ohm. So you write here 4 ohm, you write here 4 ohm, this is 20 ohm, and which is connected, these two are connected to the battery of voltage 6 volt battery. These two are connected to 6 volt battery, and again we connected to a meter and switch key. So what you have to find out here, so you have to find out that the total resistance in the circuit. It is very simple, when you add these two you will get the total resistance. What is the total resistance? Rs equal to combination of these two resistor values, that is 4 plus 20 is how much? 24 ohms. The total resistance of the circuit is 24 ohms. Okay, the current through the circuit and the potential difference across the electric lamp and the conductor. ఇప్పుడు ఏం చేయాలి, కరెంట్ని ఫైండ్ అవుట్ చేయాలి బై యూజింగ్ ద ఓమ్స్ లా. ఓకే, వాట్ ఈస్ ద ఓమ్స్ లా? V equal to IR, I equal to V by R. Okay, I equal to V by R. What is the V value? Total source value is how much? 6 volts, right? So that is 6 by 24, which is equal to 1 by 4, which is equal to 0.25 amperes. Okay, the current is flowing how much here in this circuit? The current is flowing 0.25 ampere. What is the value of the current here? 0.25 ampere. 0.25 ampere. Okay, through across 4 ohm resistor also same value it is, and across 20 ohm resistor kuda current value ela undali, same ga untadi, 0.25 ampere. In the series combination the current value is same, right? Now the potential difference across the electric lamp and conductor. So here conductor, or which is a conductor of 4 ohm, sorry, కండక్టర్ ఆఫ్ 4 ohm. ఓకే, ఈ రెండు వైర్స్లో పొటెన్షియల్ డ్రాప్ మనం ఫైండ్ అవుట్ చేయాలి. పొటెన్షియల్ డ్రాప్ ఫైండ్ అవుట్ చేయాలంటే ఏం చేయాలి? వోల్ట్ మీటర్ని ప్యారలల్గా కనెక్ట్ చేయాలి అక్రాస్ 4 ohm రెసిస్టర్. ఓకే, now you have to find out the voltage across this 20 ohm. Let us say this is V1 and let us say this is V2. Okay, then how do you calculate this V1? By using the formula Ohm's law. V equal to IR. ఇక్కడ I అనేది సేమ్, సో I is same, V1 equal to I, but resistor value is how much here across the, what is the resistor lamp resistance? That is 20 ohm. So V1 equal to, let us say this is R1 and let us say this is R2. Okay, V1 equal to I into R1, where R1 is the resistance of the lamp. Okay, now you are calculating the voltage drop here, how much voltage is here reducing. Now you see here, what is the value of the current here? 1 by 4, or we can take 0.25. I am taking here 1 by 4 to the calculate easily. So, and resistor value is how much here? 20 ohm. 20 by 4 is how much? Already you know that. Yes, how much it is? 5 volts. How much it is? 5 volts. This is how much? 5 volts. Okay, okay, now across V2, then you find the V2 value. No, V2 equal to I into R2. I is same, right? V2 is the voltage drop across 4 ohm resistor. Here R value is 4, I value is 1 by 4, 4 get cancelled, then what will you get here? 1 volt. Again, we can, when you add these two voltage values 5 plus 1, then you will get again the source value, that is 6 volt. Yes or no? When you combine these things, okay, when you combine these things, V equal to V1 plus V2. V1 value is 5 volts across the lamp. It is across the lamp, what is the voltage drop here? 5 volts. Across the conductor, what is the voltage drop here? 1. 5 plus 1 is 6 volts. This is the value of the battery potential. Okay, is it clear everyone? Okay, in this way you have to calculate. Is it clear? Right, and move on to the next question. Okay, here we have, draw a schematic diagram of a circuit consisting a battery of 3 cells of 2 volts each, a 5 ohm resistor and 8 ohm resistor and 12 ohm resistor and a plug key all connected in the series. Okay, so ఇది మనని డ్రా చేయమన్నారు, సర్క్యూట్ని డ్రా చేయమన్నారు. Then how do you draw the circuit here? Let us see, here we have, draw a schematic diagram, a circuit consisting of the battery of 3 cells. ఎన్ని సెల్స్ ఉన్నాయి ఇక్కడ? బ్యాటరీ ఆఫ్ 3 cells ఉన్నాయి కాబట్టి ఇక్కడ 3 cells. So total voltage, how do you calculate of this battery? Each one is having 2 volt, 2 volt, 2 volt, 2 plus 2 plus 2. Total voltage is how much here? 6 volt. The battery voltage is 6 volt. So which is connected to, and this circuit is consisting the battery of 3 cells of 2 volt each, and which is connected to 5 ohm resistor. Okay, and which is connected to 5 ohm resistor it is, and another one is 8 ohm resistor, right? And here we have the 12 ohm resistor. In this way you have to connect, this is, and a plug key all connected in the series. Okay, you put here one plug key, this all connected. Then how do you take the arrow, how do you keep the arrow mark? From current flows from positive terminal to negative terminal, so you have to put the arrow mark like this. Okay, so in this way you have to put the arrow mark. This shows the flow of the current. Like this you have to keep the arrow mark. So current flows from the positive terminal to negative terminal. Okay, now this is about the schematic diagram, right? So in this schematic diagram, now in the next question they have asked for, redraw the circuit. Question number 1, putting an ammeter to measure the current through the resistor and voltmeter to measure the potential difference across the 12 ohm resistor, and what would be the readings in the ammeter and voltmeter. Okay, so you have to find out the current in the circuit. Okay, how much current is flowing in the circuit, and you have to calculate the potential drop across 12 ohm resistor. Again you have to redraw this, right? Redraw this. Okay, this is a battery of 2 volt each, like that, sorry, cells of 2 volt each, and to this we are connecting the one ammeter. Okay, ammeter, this is the ammeter. So this side is attached to the negative terminal, this side is attached to the positive terminal, and also we have to connect one key, okay, to this circuit. Again you join this circuit with the wire. Okay, now you see, already we know that. Again you are redrawing. So how much resistance we have? 5, 8, 12. Okay, here what is the resistor value? 5 ohm, and this is a 8 ohm, and this is a 12 ohm. Am I right? Yes, 5, 8, 12. Okay, now what you have to do here? What you have to do here? So you have to find the what would be the readings in the ammeter. What would be the readings in the ammeter and the voltmeter? Then where we have to connect the voltmeter? So voltage difference across the 12 ohm resistor we required here. So you connect the voltmeter across the 12 ohm resistor. Okay, we have to connect this. So in this way you have to connect. The total battery voltage is how much here? 6 volts, right? So these two parameters you have to find out. Then before that you have to find the total resistance in the circuit. Then how do you calculate the total resistance in the circuit? Right, R equal to R1 plus R2 plus R3. Already you know that formula, right? R equal to R1 plus R1 plus R2 plus R3. What is the value of R1 here? 5, 8. R1 value is 5, R2 is 8, R3 is 12. 5 plus 8 plus 12. ఎంత అది? 8 plus 12 is 20 plus 5, 25 ohms. How much it is? 25 ohms. This is the value of R. Then value of current, how will you calculate? Which is how do you measure the current? By using this ammeter. Ammeterలో రీడింగ్ ఎంత చూపిస్తుందో అది మనం ఇప్పుడు క్యాలిక్యులేట్ చేస్తున్నాం బై యూజింగ్ ద ఓమ్స్ లా ఫార్ములా. I equal to V by R. What is the battery voltage here? 6 volt. Total resistance is how much? 6 by 25. Okay, you make the denominator into 100. To that what I am doing here, I am multiplying 4 by 4. 6 4 is how much? 24 by 100. Then current value is how much here? 0.24 ampere. Then how much current is flowing in this circuit? 0.24 ఆంపియర్. ఎంత కరెంట్ ఫ్లో అవుతుంది దీని నుంచి? 0.24 ఆంపియర్ ఫ్లో అవుతుంది. దెన్ యూ హ్యావ్ టు క్యాలిక్యులేట్ వోల్టేజ్ అక్రాస్ 12 ohm resistor. So voltage across 12 ohm resistor, voltage equal to, already know the formula, that is I into let us say this is R3. Okay, this is R3 and this is R2, this is R1. Okay, voltage across 12 ohm resistor means the resistor value is 12 and the current is flowing how much here? What is the current value here? How much current is flowing through this circuit? How much current is flowing? That is 0.24 amperes or 6 by 25. You can take 6 by 25 or 0.24 ampere. This is the current. So how much current is flowing through the each resistor? That is same 0.24 amperes. Then R3 value is how much here? 12. Okay, you do this calculation. 12 4 is 48, 12 2 is 24 plus 4. Okay, am I right? 12 4 is 48, 4, 12 2 is 24 plus 4. Okay, 28. So after 2 digits you put the point here, that is 2.88 volts. Okay, in the question they have asked for only voltage across the 12 ohm, but if you want to calculate the voltage across the R2 or R1, and then you can calculate. Then check this. Okay, you find it now. Voltage across the 8 ohm resistor and voltage across the 5 ohm resistor also. Can you calculate? Yes, I am doing here. Voltage across 8 ohm resistor I am finding here, that is I into R2. What is the I value we have here? That is I value is same 0.24 and the R2 value is how much here? 8. 0.24 into 8, 8 4 ja 32, 8 2 ja 16 plus 3, 17, 18, 19. Okay, how much it is? 1.92 volts. V across 8 ohm resistor is 1.92 volts. Similarly, you find the voltage across the 5 ohm here. 5 ohm దగ్గర కూడా ఎంత డ్రాప్ అవుతుందో ఫైండ్ అవుట్ చేయండి. 5 ohm equal to I into R1. Okay, voltage across 5 ohm, right? Circuit లో flow అయ్యే current అనేది always same, that is how much, 0.24, right? 0.24 into what is the value of this R1 is 5 ohm. Okay, so 24 into 5, 5 4 ja 20, 5 2 ja 10, 11 12. After 2 digits you put the point, 1.2 volts. Okay, when you add all these values you have to get 6 volts. Check this, you are getting or not here? V equal to, already you know that, V1 plus V2 plus V3. When you add all these things, 2.88 plus 1.92 plus 1.20, you will get 6 volts. Okay, is it clear? When you add all these things you will get 6. Okay, yeah, in this way we can calculate. Is it clear everyone?